Oh, good morning. This is Mr. Courtland, automotive mechanic. If you're new to our channel, kindly subscribe to our channel as a way to support us and educating you on how to solve problems that may occur on your car as you drive and use it daily. And if you've already subscribed, you're welcome to our channel. We upload video here randomly as problem comes, and we also try to attend to questions that has been asked by some of our subscribers. So if you ask us a question, to give us time, we're going to reply you as best as we could regarding to the problem that made you to ask us the question. So today we're going to be teaching you how to test this block expansion valve, to know which one that is good and which one that is not good, especially if you are within some sort of a restricted area like in Africa, where most of the parts you're going to be getting at a cheaper rate to get your job done is used parts. So either way, if you still have someone that maybe you have a car and you want to rule out if this is the problem that you have, I think this video is also going to help you also. Then in order, if you also watch this video, it's also going to educate you to know some other functions about this, how this metering device work, different from what you've been seeing on YouTube and some other internet. Okay, without wasting much of your time, let's get to it. If you've already subscribed, let's hit the road and get started. So this different expansion valve is what I got out from different car makes models that I've been working on for years. This one here is for W203, aka C200, C230, C240 Mercedes, and this one here is for Toyota model, Honda, Asian model mostly. This one here is a typical Denso expansion valve, block expansion valve for Corolla models, Corolla S, Corolla LE, CE, and all that. And this one here is for Peugeot 406 Prestige, Comfort, and some other makes. Okay, the main reason why I put some of these valve, for obvious reasons, is that some of them are defective, and the non-obvious reason is that we're changing a compressor on the system and we want an optimum performance and we don't want any compromise in the cooling. So I decided to put it off and replace them with a brand new one, so I wouldn't have to do the job twice or remove the refrigerant, which is going to cost me more money. Okay. One thing I want to say to you in order to align your mind about this is that, contrary to what you've been told, this is thermostat right on top here, and it uses the spring as its sensing bulb to sense the temperature of the refrigerant that is being compressed into liquid, into gas, and condensed back into liquid through the condenser to be passed into this evaporator that is going to be located under your dash. Okay, so for this very Denso model, Denso fits quite a lot. It's not only for Corolla, it also fits for Lexus. This very evaporator is for Lexus, but this very valve also fits it. If I fit it right now, it should be able to fit it perfectly. Okay, you can see it. Let me come a little bit so you can see it. So there is no any gap in there. It fits very well. So as it sets this very well, this very way, one of the tests which I'm going to be showing you, which is the main reason for this video today, is on testing which of them is effective, which of them is not effective, and without using any tool. So let's get to it. So if you see on this expansion valve here, there are two sides. This is the outlet and this is the inlet. You can see some of them, you can be able to notice that the inlet is where you can be able to tighten your suction side and your low liquid liner pipe through the other side, where you use this very thin 10 bolt here to use your 10 knots to fasten them, while this one here is some sort of a Allen bolt, which is going to be holding this evaporator back to the expansion valve so it doesn't pull off when the pressure build up. We're talking about 100, 150, 200 or 300 psi on the high side. Okay, now one experiment which I've this information I'm about to share with you is actually drafted from experiment which I've been doing on cars and working on some other different cars. Is each time you are adding a refrigerant inside a system using maybe this kind of a can tap or any kind of a can tap, after unscrewing them, there is something that you didn't notice quite well. This one is just some little air that is trapped inside there. So if you notice some of the ones that you've pierced, like this one here, I have some sort of my own belief that the main reason for this metering device is to reduce the liquid to some certain level, not to allow it to go in too much and not to allow it to go in a little bit too restricted. So those were drafted from this. If you see how this is pierced, when you are letting the refrigerant go inside here, does get cold. This very can does get cold. And another side that get cold is the very suction pipe where you are letting in the refrigerant to go through. If you don't let the liquid to go in very fast, but you just keep the can this way up and you shake it, wiggle it while it allow it to go in, you're gonna be feeling here to be cold as much as the suction pipe. So that is what actually got me to actually believe that this expansion valve, which is also called a metering device as the name implied, is been engineered to meter the refrigerant to some certain range which they have. And how this gets very bad can be often with different things here. If this thermostat here gets sticky, that it will move up when this sensing board inside here sense the heat that is in the refrigerant, refrigerant that has been converted to liquid from gas by the condenser after being compressed in high volume. The same high volume compressed into this that is take to compress the refrigerant into this very can here. So when the compressor does that job, then this metering device have to reduce it in such a way that's going to go in as a liquid, not gas. Now when your system start becoming inefficient in cooling, it means this metering device is acting rude. I mean, it's now not letting liquid to get in but allowing the refrigerant to go in as gas, because when you reduce it so much, when you reduce it from going in as liquid, it goes in as gas, and in gaseous form. And when it goes in gaseous form, the system is going to have a terrible or poor cooling. So now that is where I derived the analogy of how this very thing worked and how to test it even without the system, without it being inside the system. So like I earlier said, first thing first, if you see some of them, you can be able to know that this is the inlet and this is the outlet. How? Because you can see the both which they're using fitting the suction side as much as the high side. So in order to test this to know if it is working, that is why I have this or this some of these, so that you can be able to know them. For this one here, it doesn't have a spring, but it have a sensing bulb inside which looks like a ball bearing. If you look very well, you can see it right there shining. So how do you test this without using any tool? That is my question. That is a lot of question that a lot of people are having right now. So for those who already trusted some OEM or aftermarket part that can actually do very fine, like Four Seasons, I have used Four Seasons a lot. Four Seasons is very good, better than some stocks and some OEM. The one way which we use in testing it is by fitting your lips to this very low high side here without any air and try to force air through it. If it is tight and restrictive, when you push air through it, when you pressurize it with your mouth, force air through it, it means it's going to be defective. If it's allow it freely, it's going to be more effective. Now I'm not going to put the camera on my face. I'm going to blow it so you can be able to hear it from different expansion valve and know what it should sound like when you have a good one. Let's start with this one that is defective. You can see it won't even allow any air to go through this side to come out from this side when you blow air from this side. So this one will definitely not work. In fact, it's going to be, the suction side is going to be warm somewhat, while the high pressure side is going to be very, very hot, not even warm to touch. Let's check this Peugeot. I like Peugeot. I think the Germans that engineered their expansion valve kind of did a very good job there because they hardly fail. So let's blow to this, blow in from here, not this very part here that fits into the evaporator. Now listen, you can see that. You can, let me blow this so you can know the difference. You see, this is so restricted that you can't even go through. Why this one here? You see, so I can, without anything, I can be able to tell you that this one here is going to work very efficiently. And remember what I told you when I pulled some of them, I pulled it because I'm trying to replace the compressor and I don't want any restriction. So then let's check on this denser so you don't feel that it's only Germans that knows how to engineer things. So here is the inlet and this is the outlet where it goes through the evaporator. So let's blow this one. You can hear the sound. Now let's blow this other one here also. This one here is not OEM, but this one here is denso, but this is not denso. So let's still blow this one and see what we're gonna get. Okay, so you see that this one here and this one almost sound the same, except this. And guess what? The system that I removed this one from, it is very, very terrible. So guys, now you've known how to test a block expansion valve for cars without using any tool, but just using your mouth and pressure. If this helps you to eliminate the problem you're having to solve in any car make or model, give us a thumbs up, like, and share with your friends. Hope to see you some other time. This is Mr. Cool Auto Fix. Bye for now.